Welcome to the fifth week of the course Energy Economics and Policy. During this week, we will be discussing about the economics of renewable energy, and today we will discuss a few facts in order to set the context. So this is our module 3, and we have already covered the first these four topics under module 3, and during this week we will be covering the last one. These are the few material that you can go through if you want more information and an in-depth understanding of these issues. As I go on with the slides, I'll also keep on providing you more resources and more websites to check. This is the starting point of the whole problem. Demand for energy is increasing. This is the graph which you have already come across while discussing about the energy demand. Here you see that the energy demand, the projected energy demand over the period of 2020 to 2040 is going to grow at a very high rate. And you see at the end of 2040, the projection is that the total energy consumption is going to cross 800 quadrillion BTU. Now the question is, where will this energy come from and what is going to be the role of renewable energy in the context of this growing demand? Here we can address three issues given this background. What are these three issues? The first is that the fossil fuel has a finite stock. So although at the current point, most of this energy demand is being supported by production of energy with the help of fossil fuel, but after a point of time, the stock of fossil fuel is going to go over. Then what do we do? In that case, shifting the burden from fossil fuel to non-fossil fuel and to let the technologies of renewables, that is non-fossil fuel, mature over a period of time is actually a good idea. The second is supply security. This is actually connected to the fact that the fossil fuel has a finite stock. Since it has a finite stock, after a point of time, it's going to it's going to be depleted maybe from major parts of the nation. What will be left will probably be with a couple of countries. Therefore, the whole world, if they want to produce electricity from fossil fuel, they have to depend on a handful in only a few countries where the fossil fuel is still available. That will cause a huge problem of the supply security, because whether this kind of fossil fuel will supplied by this only few countries left, those are left with this fossil fuel or not, that will depend a lot about the geopolitical scenario. So this we will discuss in some future modules later about energy security. But I would like to take you back to the context of 1970s, where the world experienced oil price shock. So basically few countries, they had the oil with them and they just did not want to supply the oil to some other countries, which led to this oil price crisis, and there was this short of oil price. So in future, as the stock of fossil fuel is going to deplete, the supply security will emerge as a very big issue. The third one, which is often, you all must have aware about that, this is the context of climate change. So the emission that comes out from burning of fossil fuel in order to produce power consists of a lot of greenhouse gases, and this causes the global warming and therefore leading to climate change. If the shift is towards renewable, it has been seen, and we will discuss this point again in the course of this lecture. What has been seen is that if you produce power with the help of renewable, through the life cycle of this renewable energy production, the emission of carbon dioxide or other greenhouse gases are much less as compared to what we get from the fossil fuel. Therefore, we can see that fossil fuel, renewables, by replacing fossil fuel can contribute in three different ways. However, it does not mean that there are no challenges associated with the shifting to renewable. There are many challenges associated with the technology, with the governance structure, with the policy, with the acceptance of renewable energy, and practical implications, for example, availability of space. So many of the renewable energy, especially for solar or maybe for biofuel, you need a lot of space in order to harness that energy. So there are real life challenges as well. We will try to explore all these advantages and challenges as we go on. A couple of facts about the renewables. On a global basis, it was estimated in 2016 that renewable energy contributes approximately 14% of total primary energy supply. Now, the concept of total primary energy supply, if you want to revise a bit, I would request you to go back to week 1 when we discussed the energy balance table and we came across the idea of total primary energy supply. However, one point of note is that that is not the only way how total primary energy supply can be measured. There are other ways as well, but basically the idea is more or less same. So renewable accounts for 14% of TPES. However, renewable is not one homogeneous category. If you look at this chart, you will see that the whole system of power production or the supply of renewable energy is actually dominated by coal, which actually contributes 27%, natural gas, which contributes 22%, and both primary and secondary oil, that is oil and oil product, which contributes 32%. There is a 5% contribution from the renewable, and this is the 14% contribution that you are getting. The 5%, there is a 5% contribution from nuclear, and here you can see that there is a 14% contribution from the renewables. So this 10% is actually coming from biofuel and waste, 2% from hydro and geothermal and solar, etc. So you can see hydropower, geothermal, solar, wind, etc., etc. They are contributing only 4% of total primary energy supply in 2016. Why is this the case? This is because although we come across a lot of technological interventions and a lot of options with renewable energy, a number of them are matured and they are quite able to compete in a competitive market with non-renewable energy supply. But most of the technologies, or I would say many of the technologies, are actually still too mature. So the important point is that if you think about the renewable energy, it's about different use of different technology. So some technology are matured, some technologies are not. So, harvesting those immature technologies which may play a big role in the future is one of the big policy challenges. The last point is about India. About 20% of installed power capacity in India is renewable in 2018. The goal is to achieve 40% electricity generation from non-fossil fuel sources by 2030, and this is the commitment that India has done under the Paris Agreement, which took place in 2015. So if you look at the policy document, the energy policy document of India, you will see that there is a lot of shifting focus in favor of renewable energy, especially in the favor of solar energy. As we have discussed that there are multiple technologies available in order to harness the renewable energy, here we are going to discuss about 5 major renewable energy technologies. If you want to know more about them, you can visit this 5th assessment report of the Intergovernment Panel on Climate Change, where they are discussing more about these technologies and some other technologies as well. Starting with the solar energy, so what does the direct solar energy technologies do? They basically harness the energy of solar irradiance to produce electricity using 2 different technologies. One is the photovoltaics technology called as PV, and the other is called concentrating solar power, CSP. So these energy are used to produce either thermal energy, for the further use of heating and cooling purpose, or they are used directly to meet the lighting demand. The second one is hydropower. So hydropower, especially the large hydropower, is a mature technology which is in place for many number of years. This harnesses the energy of water moving from some higher to lower elevation, primarily to generate electricity. However, other than generating electricity, it produces a lot of co-benefits in terms of supply of drinking water, irrigation, flood and drought control through the setup of dam, and for navigation as well. Not only that, some of the hydropower project sites, they emerge as a tourist spot. So there are a lot of co-benefits generated by the hydropower projects. However, there are conflicts as well. There are social costs as well. The interesting part is that when we talk about the cost of electricity which is being generated, we often do not take into consideration the benefits that are generated along with generation of electricity. So this is something you can, you can recall the discussion about the economic cost and financial cost. So and similarly economic benefit and financial benefit. So all these co-benefits that we are discussing, they are more sort of a economic benefit to a hydropower project, and they will be discussed in some other context as financial benefit. The third one is the wind energy. This harnesses the kinetic energy of moving air from large wind turbines. It can be offshore or onshore. So one is inside in inland and the other is in the not in the inland offshore. This technology is actually matured, but wind technology has faced a lot of challenges when it comes to the question of deployment. The challenges are not only technological or financial. In many cases, the challenges are cultural as well, because it changes the whole landscape. And you will see that in many places, especially in in the context of Europe, there is a large literature which shows why people didn't actually like the wind energy, the wind turbines which are visible in the locality. The fourth one, this is geothermal energy. This utilizes the accessible thermal energy from the Earth's interior. So hydrothermal power plants and thermal applications of geothermal energy, these are the mature technologies. While there is another technology called enhanced geothermal system, EGS. These are in the pilot phase. So a lot depends how this particular technology will mature in future in order to ensure the future of geothermal for us. The last one that we are going to discuss is bioenergy. And if you recall the previous pie chart, you will remember that a lot of contribution is actually coming from bioenergy and waste. So this can be produced from a variety of biomass, including the forest, agriculture, livestock residue, etc. You can also use the organic part of the municipal solid waste that can be used in different forms of technology, including the small and large scale boilers, the domestic pallet based heating system, etc. So these are more common technology, and there are some other technologies which are still to mature. So the important point of discussing these three renewable technologies is that you can see that other than large hydropower is generally mature technology and it's commercially viable. Other than that, for all the options, the solar power, the wind energy, geothermal, bioenergy, there is not one technology which actually harnesses this kind of energy. So it depends more on in the future how the technology that are not matured yet will mature in future and come into the force in order to harness this kind of power at a very cost effective manner. So this is what we have to wait and see. However, the good news is that the global new investment in renewable power and fuel is actually growing. This is the data from 2008 to 18. If you look at this, from 2008 to 2018, there is almost a steady growth in the investment in renewable power and fuel, other than few fluctuations. So these fluctuations are because of various reasons. The other interesting fact is that if you look at this bar, each bar consists of three parts. So the bottom one, this light blue part, it actually shows you the investment from the developed countries. So which is of course dominating, that you can see. The second part is the developing and emerging countries, and the last, that this dark blue part, the top part, is the investment that is being added by China. So if you can see initially in 2008, 2009, 2010, you will see that the investment was largely dominated by the developed countries. Only a small portion, maybe one-fourth, was coming from the developing countries and emerging economies. As we move on, you see a large part is now actually coming from developing countries, with a major contribution made by China. So China's role has become really, really important if you think about the new investment in the new renewable energy projects. So some of the facts are as follows. Investment in renewable power technology accounted for 65% of the total of all new generating capacity. So it has been growing a lot. The second fact, which is quite interesting, is that the overall investment, if you include hydropower, in 2018 actually far exceeded the investment in fossil fuel and nuclear power capacity. The third point is that the decline in investment, you can see there are some departure from this growth, right? So there are some points where there are decline. So if you look at this point, actually the investment has declined from 2017 to 2018 by around, some 22%. Now, it might seem that there is a decline in investment, but this is due to a good reason. The reason is that the unit cost of solar power has come down. Therefore, it requires less investment. So, this is another message that we can take from here is that so it's good that we are getting an increasing trend of investment, but it's also good to observe that the cost of these technologies are coming down. As a result, the requirement for investment is also will come down in future, or the same amount of investment can actually harness a lot more amount of renewable energy. The final, this we have already discussed that biomass has a major role to play in the context of renewable energy, and the investment in biomass and waste to energy has increased significantly over the years. Taking the point that the cost of renewable is declining when the investment is increasing, these are two very interesting diagrams. Also, I have taken this from the fifth assessment report from the Intergovernmental Panel on Climate Change. And in this panel, what you see is that if you look here this blue line is actually plotting the produced silicon PV modules at a global scale and the average price of this silicon PV module. You see that the price has, this is the cumulative global capacity. So you see, as the cumulative global capacity has increased over the years, the average price has declined. Or you can interpret it in the other way. As the average price declined, the cumulative global capacity has actually increased. So this is where we were in 1976. The price was 65 USD per watt of power generation, and it has come down here, whereas the capacity has increased a lot. It has come down little over 1 USD per watt. So there is a significant decline in the produced silicon PV module average price measured in 2005 unit per watt. The same is actually happening for the onshore wind power plants. So these two orange lines, they capture the increased capacity of these offshore wind power plants in Denmark. So this is for Denmark and this is for USA. This has also come down. So there is a slight increase in the last few years, but the general trend is actually decrease in the price. Here you can see that not only the wind and solar power, for the wind and solar power, but price is actually declining for the biofuel as well. So here the cumulative sugarcane production in Brazil has been plotted, whereas here you see the average production cost of ethanol. So the trend is not as significant as you see in case of solar or wind, but it shows a declining trend. So there is a significant advancement in the RE technologies leading to decline in long-term cost over time. However, when we say that the cost is declining, one issue with the renewable is that since there are various technologies available, the cost of energy production also varies a lot. So in this diagram, you will see these are the different technology options on the vertical axis that they are available for energy production. And here you see the cost of production USD. It's a constant price in 2005, constant price per gigajoule. So you see, you take anything, for example the solar electricity, which gives you the highest variation. So there is a range of options available, and what you can see is that in some cases the production of electricity from solar energy can be very, very low. It can be less than less than 10 cents per kilowatt hour, whether in some cases it can go up to this point as well. So it all depends the technology which actually represent this particular section, how they mature and how the cost of production of power through these technologies actually come down and contribute to this area. So this is the important part of generation of power with the help of renewable energy. Since there is a lot of variation, the levelized cost of energy from RE from many cases actually remains high as compared to the conventional power generation system. For example, if you think about this particular technology of solar electricity or this particular technology of solar thermal heating, of course the price or the cost is going to be much higher than the conventional way of producing the power. Therefore, what we can say that although renewable energy has become economically competitive, in many cases there remains large number of deployment challenges when we talk about the technologies which are not mature yet. If you take the example of solar, there are various factors why that these technologies are facing challenges or difficulties in terms of maturity. If you think about the solar power, the regulatory and institutional barriers are the issue of integration and transmission. So that's the major issue related to solar power. For hydropower, there are a lot of, the technology is already matured, but there is a lot of social and ecological impact which is discussed when the implementation of hydropower is there. For wind energy, public acceptance issue is always there. This is something we already have discussed. So you can see it's not only the financial cost that matters, there are a lot of other economic, social or policy related barriers that are there in order to create some sort of an hindrance in the implementation of renewable energy. And it's not very wise to ignore these hindrances because sometimes they are very logical. So therefore it's very important to pay a good attention to those hindrances and see how these challenges can be overcome. As we have said that the generation of electricity from renewable in most of the times is higher than the cost of production of electricity from conventional sources. However, when we talk about the cost or we talk about the benefit that we derive from renewable energy, oftentimes we do not take into consideration all the economic benefit that is being generated by the renewable energy. For example, these numbers are interesting. The life cycle assessment for electricity generation indicate that greenhouse gas emission from renewable energy technologies are in general significantly much lower than those associated with fossil fuel options. Coming to the numbers, the median value for all renewable energy will range from 4 to 46 gram of carbon dioxide equivalent per kilowatt hour of electricity generated, while the same for fossil fuel will range from 469 to almost 1000 gram of carbon dioxide equivalent per kilowatt hour. So the interesting thing is that even if you take the highest, the highest range of the median value, this is 46 gram of CO2 equivalent per kilowatt hour. And if you take the lowest bound of the CO2 emission from the non-renewable energy, this is 469. So it's, I mean, the high, this 46 is actually 10 times lower than the 469. So the emission, if you think about the context of greenhouse gas emission, then that from renewable resources are much, much less as compared to the non-renewable energy. However, sometimes it becomes difficult to capture the benefit in terms of constructing the cost that is associated with the non-renewable sources. Why is that so? Because here, see, there is the avoided emission. So you are avoiding producing something which is bad. However, there is no market or there is no matured market, I'll say. There are certain markets where you can do some sort of a carbon trading, but a vast global traditional market yet to emerge for CO2, the buy and sale of CO2 credits, which can encourage actually the incorporation of this kind of benefit where the total benefit of renewable is being calculated. However, this is not the only issue to look at, but there are other broader, economic, environmental and social aspects which generate a lot of benefit when there comes the question of renewable energy deployment. And as we are thinking about the cost benefit analysis, in the economic terms, it's very, very important that all these environmental, social and economic costs and benefits are taken into account to compare the renewable and the non-renewable. Finally, before I end this section, I would like to draw your attention to the classification of goods. These are the concepts that we are going to use in the next slides or next lectures. And here it might seem a little out of the place, but you will be able to connect the concepts as we go along. So in economics, the goods are classified in four different manners. What are these four different kind of goods and services? They are the private good, common property resources, artificially scarce good, and the public good. And what we are most interested in is the concept of public good. So these four types of categories are derived based on two properties of these goods and services. One is the property of excludability and the other is the property of rivalry. So if you think about a purchased cloth that you have paid a price and you have bought this from the market, this is a typical example of a private good. This is excludable because if you don't have the money, then you don't go and buy it, and therefore you can exclude those who do not have the purchasing power from the use of this particular goods and services. Why are they called rival? They are rival because if you have purchased and you have been using the particular cloth, then the same cannot be used by somebody else. So private goods are characterized by excludability as well as rivalry. Whereas public good is just the opposite. This is characterized by non-excludability and non-rivalry. Before I come to the example of clean atmosphere, I'll give you another example, which is a non-crowded road. So if you walk on a non-crowded road, then it is non-excludable because you are not excluding anybody else to use that road. Somebody else can also come and join the walk with you. And secondly, this is non-rival. So because this is sort of an not crowded road, so the benefit or the joy that I am deriving out of walking on that road will actually be gained by somebody else as well. So this is non-excludable and non-rival. Now the problem with non-excludability and non-rivalry is as follows. Because I'm not excluding anybody and because I'm not creating any rivalry, nobody is willing to pay for this kind of a public good. So clean atmosphere is another example. So we all derive benefits from clean atmosphere. So if I derive some benefit, it does not hamper your entering to the same use pattern. And the second thing is that it's non-rival in nature. As a result, clean atmosphere is more like a public good. As we emit more of greenhouse gases or local pollutants, we actually emit it in the clean air. So if you think clean atmosphere is a private public good, then the polluted atmosphere is basically a public bad. And given the property of a public good, nobody is willing to invest or willing to pay in something which is non-rival and non-excludable. Therefore, investment in public good is a big challenge and it rarely comes from the private investors. Therefore, you will see things like road, big power plants. These are all built by the government in many of the cases. The other two examples are, this is non-rival but non-rival but excludable. These are called artificially scarce good. A film watched in a theater hall can be an example of that. And the final one is a grazing ground or the atmospheric capacity, which are rival but non-excludable. So atmospheric capacity is not excludable but rival because as you keep on adding more CO2 equivalent in the atmosphere, the capacity of atmosphere to absorb more and more CO2 is going to be reduced. However, in the discussion, we'll come back to the concept of private good and public good as we go on, and we will see how renewable investment, renewable energy has the properties of public good, and therefore there is additional policy intervention which is needed in order to promote renewable energy in the context of power generation or the sustainable use of energy. Coming to the end, following are the observations that we are going to make. In order to accommodate the high renewable energy share, the energy system will need to evolve and be adapted. Long-term integration efforts could include investment in enabling infrastructure. This is important because again, they have the public good characteristic. Modification of institutional and governance framework, attention to social aspects, markets and planning, and capacity building in anticipation of renewable energy growth. Furthermore, the integration of less mature technologies may play a very important role but will require continued investment in research, development and demonstration, capacity building and other supporting measures. If you want to read more on this chapter, I would urge you to go and visit this particular website and read this summary for policymakers. Thank you.